In this video, we will learn about entropy and entropy change for JEE and NEET. In second law of thermodynamics, we have a heat engine which extracts heat from a reservoir at high temperature but does not convert it totally into work, and some amount of heat is rejected. Depending on the process utilized, we have varying amount of work done by heat engines. Entropy is the measure of disorderness of system or randomness of the system, explains why the total heat is not converted into work. The other statement of second law of thermodynamics, which says that heat spontaneously flow from high temperature to low temperature and not from low temperature to high temperature, is also explained using entropy and entropy change. It says entropy of a system either remain constant or increases. It never decreases. That is, disorderness of the system always increases or remain to the same level. Entropy is not represented mathematically, but change in entropy delta S is given by Q, the amount of heat involved in a reversible process, upon temperature, which is used in Kelvin. Even if the temperature is varying for the process, then we can simply calculate the integral, that is delta S, as dq reversible upon T and its integral. So this will give us the change in entropy. The only restriction here is that process should be reversible. That is, entropy change can be mathematically calculated only for a reversible process. But there is a relief that entropy change delta S involved in a reversible as well as irreversible process between same two states always remain same. That is, I have two states and two connected paths, that is processes. One is reversible and other is irreversible. Then entropy change calculated in the first part, say delta S1, and the entropy change which will be for the reversible path, say delta S2, are equal. That is, delta S2 equals to delta S1, and we have mathematical form to calculate delta S1 because process 1 was reversible. Hence, we also know the change in entropy for irreversible path. Let us see entropy change with a process. Say I have a process between two systems, that is, two bodies which are interacting with each other in a reversible manner. Say the process is from 1 to 2, that is, one supplies heat to the second. We call the process reversible when at any point of the path the process is equally capable to move in either direction. That is, with slight change in conditions, you can move the process in either direction. Let us say these two bodies are at same temperature and we are heating the first body very slowly so that its temperature rises and it transfers heat to the second body. Now if I reverse the condition slightly, that is, now I supply the heat to the second body, then the direction of flow of heat will also get reversed. That is, heat will flow from second to the first. So this will be called a reversible process. Hence, the amount of heat supplied by the first to the second at any time, dq upon T, will be the increase, the change in entropy of the two, whereas the amount of heat lost by the first, which will be minus dq by T, will be the change in entropy of the first. So as we can see here that delta S1 plus delta S2 is 0. That is, here what we see that total change in entropy is 0 and therefore entropy remains same. But if we have a process in which heat transfers from a higher temperature to lower temperature spontaneously, then the process always leads to increase in entropy, or change in entropy will always be greater than 0. Thank you.